of the power of quantum computing and quantum computers. And what does creating a quantum smart workforce require? So the report kind of has some ideas about this in it. All right, so yeah, two big prongs: K-12 education, university investment, plus industrial partnerships, industrial university partnerships. This one, I think, is pretty evident from all of us sitting here. I mean, you are part of the quantum smart workforce. But this partnership with industry is pretty important because they're on the ground and kind of know what exactly is needed. What do we need to know to do what they're doing? What do we need to, how do we need to be able to communicate to be effective, at Google in their quantum division? The one that I think is kind of interesting is the K-12 education piece. Do you think that elementary school kids could learn something useful about quantum mechanics? Everything we told you is wrong. In college, let's start all over when our brains are already cemented and we already thought we knew what was going on. 100%. I think this is a really important point. Kids are so smart. I have an 8-year-old, and I'm constantly flabbergasted at what she could do when she was 3. And yeah, she's learning algebra now because she goes to fancy math schools that do these things. And I'm like, man, I didn't learn that till high school. So yeah, kids are very capable of grasping things, especially because they don't have any preconceived notions about what's weird. Yeah, I think that this is such an interesting thing. I think that even when we go out on K-12 outreach, I think we underestimate the youths. I think that we still need to learn how to talk to them with words they'll understand. But I think they can understand some pretty sophisticated concepts. And if you started early enough, I think that we would get kids in college and coming into grad school that this was all not weird to them at all. So I do really like that point. And I think it wasn't necessarily developed as well as it could have been in the report, but I do think it's pretty important. So a few other things in the report that I think are worth mentioning are the fact that to really capitalize on the quantum, on what's coming along in quantum computing, we have to support these other technologies that are going to be absolutely essential for them working. So things like cryogens. How many people have heard that getting liquid helium is hard? Everybody, right? Yeah. There's, especially if you go the photonic quantum computing direction, really sophisticated, photonic, super fancy lithography kinds of things are needed. Microwave amplifiers, other types of nanofabrication. Yeah. Any other quantum supporting technologies that you think weren't necessarily listed in the report? The other thing that I thought was interesting about the report is, it takes a very nationalistic viewpoint on why we should be doing this. And the things they list are first, military capability, second, economic productivity, and third, international competitiveness. And maybe international competitiveness is up there higher. How do you guys feel about that? It is interesting to see what academics, put in the intros of their talks versus what is kind of in the intro or in the, priority list of this report. Yeah, there are very many positive applications, for sure, even in defense and military. But, I don't disagree. I don't disagree that that's why they put it here. It is terrible. And, as a scientist, I think about things like this a lot. I think about, so I've talked about nitrogenase a few times, and the classic example of Fritz Haber's discovery of the Haber-Bosch process, and that enables 50% of the population on the planet to exist, and 50% of the nitrogen in our body comes from that industrial process. But all of the research that went into that, enabled chemical warfare, and he was not a good person. So there's a lot of interesting ethics to think about in this field as well. And maybe the last thing I'll leave you all with is, because we're kind of on that topic, and we just have a minute left, is this last one. So Soto brought up this interesting idea about accessibility and economic inequality as this technology really comes online. What did you guys think about that? Yeah, it's going to be interesting, and this stuff's going to happen in your lifetime, right? So I'll be very curious. There's other perspectives on this, right? There's perspectives that this is all hullabaloo, and there's going to be no quantum revolution. So, I'm not going to take sides, but like we're in a class on quantum information, so let's talk about it. But I think there is, this is all like the world in which this does happen. And there is a world in which it doesn't happen because of the things we talked about at the very beginning. So